Brandon and Julia, welcome to our class in statistics. This is a short class, but it's going to be, we went over the activity with the United States. It was on day one notes, so you may read the directions there and finish that and tell me your results when you can. I also collected the homework. So let's look at our next way to make a sample. It's called stratify. So let's call it more sampling methods. And the first one, there's only two today, stratified. So a stratified random sample, I'll put random sample. Unfortunately, we don't have a nickname for him, because if we did, it would be SRS. So we already used SRS. So we just call him stratified random sample. The stratified random sample is used when the SRS is not practical to use. So what we do is we're going to take the whole population and divide it into strata. And a strata is, like, say if you're looking at the Grand Canyon, have anyone seen the Grand Canyon? It's got these horizontal layers from the top to the bottom, also called strata when you're looking at rocks, and strata when you dive down into the ocean and dig into the bottom of the ocean, dig down into the earth. Any layering that we've seen in our science classes and other places are called strata. Same thing here in stat class. So we're going to classify the population into groups called strata. And let me tell you what a strata is. So first I'll say divide into strata. And a strata, what's that? A strata is a division where the group that I've divided the larger group into has similar individuals. So we'll say a part of the population with similar individuals. So the individuals in one strata are more like each other than they are like the members in the next strata. So let's look at an example.
Is that why you have seniors and juniors?
Yeah, eventually. We're going to make a strata and a cluster out of that. So you're on the right wavelength though. So what we're going to do is divide the whole population into groups that are like each other. Everyone in a strata has very similar characteristics, different from the next strata. So we're going to divide the whole population into a strata. And when we do that, we're then going to take a simple random sample, an SRS, in each strata. So we might take 5 out of each strata, and we will get those values randomly. Then choose a simple random sample from each strata for a given number. So maybe you want 5 out of each strata, or maybe 2, or whatever, or 100 out of each strata, depends on the problem. It's kind of amazing. SRS seem very powerful to us, but actually a stratified random sample sometimes is better. It's more precise than the simple random sample. And the reason that is sometimes when you when you make strata, it actually takes the variability of the whole population and reduces it. So we'll see that in action in a little bit.
But then,
All right. All right, so if we were going to take this school and form strata out of it, say we don't want to ask every single person the questions on our survey, one thing we could do is divide it into house. So each house, oh, not house, that's different. We have to divide it into classes, like you had just inferred. So we have freshmen, they're all like each other, but they're very different from seniors, at least in your viewpoint. From my viewpoint, they don't look that different, but from your viewpoint, they look hugely different. So, 9th graders,
They're not that
10th graders, 11th graders, and 12th graders. So, that's an example of a stratified population. So, what other strata could we come up with? Age is often a good one. So, say you had a huge church and you wanted to know, have a survey. You could take, the young people, the middle-aged people, and the older people in like manner and form strata. Then you would do a simple random sample within each strata to get the number of participants that you want. All right, let's look at another one and the second kind of sampling we're going to learn today. And then we'll do an example where we have to first do it with strata and then with the other way. Another way, so if this is the first one for today, the second one was the clusters. Clusters is the next type of sampling that we're going to study. In this case, each cluster looks like the whole population. So here, each strata was very different from the next, and the individuals were like each other. In clusters, you have the opposite. You have everybody from the whole population is typified in one cluster. So I'll make a note of that. Each cluster looks like the population, only
Like the
smaller.
houses.
So if you look at our whole school, that's where we divide it into house. Because in the house you have all different ages, all different academic abilities, all different athletic abilities. So very much like the whole population. Each cluster looks like the entire population. So then you have a number of clusters, and you do an SRS to choose whole clusters to survey. So use an SRS, a simple random sample, to choose the clusters to survey, or find the sample for, I'll call it, to survey. So suppose you're in a school that's quite large, and say there was 18 homerooms similar to your houses. So I want to sample from this huge school, so I would look at all the homerooms and I would throw the 18 homerooms in a hat, or I'd use my calculator random generator or my table, and I put 18 in that, and I would draw out, say I wanted 5, and I would survey everyone in those 5 clusters.
How come the calculator thinks it can be random?
How come what?
The calculator can be random.
How come this table can be random? I don't know.
No, it can't be. Like, I don't understand. Is there even such a thing as random?
I know, those are very good questions, and I have the same ones.
Well, how do you know how it generates it?
I do not. I don't know how they generate that table.
Well, probably generate the table through this.
Yeah, but what came first, the table or the calculator? That's a very good question. I have not the answer.
Because they have like
So,
random, generator like
Look
dice
it
and
up
stuff in
and
video
tell
games.
me. All I know is it's random and it works.
But is it random?
But
The
is it
calculator has
truly
a mind of its
random?
own.
It's kind of interesting because I'll go down a long list and you'll see numbers repeated and stuff, so it's quite interesting.
But you won a 50. I got 2 14s in the first 5.
Yeah. Really?
Yeah.
So how is,
Really?
no way.
That
Oh,
can't
that
be.
sounds alright.
All right, I think that's it. So we are going to, if you just look, you can tell by looking at the book where I've just introduced clusters, and I'm going to start this example where you have people in an auditorium, and I was going to do a stratified random sample, and then I was going to do clusters. So I'd like you to read about that. It's in, what was the pages, 15 to 19?
15 to 19.
219, right. So if you would find about where I was in the lecture and read that and complete those 5 problems, 17, 19, 21, 23, and 25. I don't think that you'll have any problem. If you do, just read those pages and it'll clarify. All right.
Do you want us to also do the